this example we will see NO, NC and coil in ladder program. What they are and how we can use NO, NC and coil in a ladder program. So NO is normally open, NC is normally closed, and coil is the output. NO and NC is the opposite of each other. So instruction is like inverted instruction. Coil is the output where things are a bit in a PLC memory turn on or off. Now in this example we have a problem, and the problem description is like this. There are three machines, each with its own start and stop buttons. Each start button is to have a ceiling circuit. Write PLC group ladder logic to operate all three machines. So we have to break it down into parts. Like there are three machines. It seems like each machines are similar, each with its own start stop button. So now we have two digital input. One is input for start button, another is for stop button. Now start button is to have a ceiling circuit. What is ceiling circuit? It's like when you press the button and then release, the machine should start. But in case the power fails, you have to redo again. You have to press it again to restart the machine. So that is called ceiling machine. Like and there are other kind of machines. You have to press the start button and the machine will start. But in case power fails, the machine will restart automatically without even pressing the start button. That is kind of set or reset instruction used for that kind of machine. But this is ceiling circuit. Ceiling circuit operates this way, that you have to press start button every time power fails. So let's go to the problem solving stages. We have a list of tags we need to prepare. So this is the list I have prepared for three machines. So machine 1 has 3 input and output, 2 digital input, 1 digital output. And the type of digital input is start button NO, that is normally open, stop button is NC. And then machine motor, that is digital output. And the same repeats for machine 2 and repeats for machine 3. So now we have the list of tags prepared. So this list we have to create in our tag table. Now I have already prepared a tag table for that. Example 1, we have a start, stop and machine 1 tag for machine 1, and then start 2, stop 2 and machine 2 for machine 2 tag, and then start 3, stop 3 and machine motor, machine dash mode MOT dash 3, that is for machine 3. And this is the address we have allocated for these three machines. It starts with the module address beginning at 0.0 till 0.5 for three machines digital input. So total 6 digital input we need for these three machines, and 3 digital output we need for the motor for each machines. Now as we have done the tag part, listing out the tag and addressing part, let's go to managing the input and output. Managing an input output, what we have to do is we have created a DB, digital data block, for DI. We named it all DI, and another DB we have created, named it all DO. So purpose of this 2 DB is like that. So when we have a PLC system, we create a data block that collects all the digital inputs and save it. And then inside ladder program, we use the DB status, not directly from the field. When we need to read directly from the field, we will discuss that matter into different video in another video. But this is the standard practice that all digital input we save the status in 1 dB, and then we use another digital output to be turned on and the status to be saved in digital data block, and then at the end of the program we actually move the status from dB into the real module, digital output module. So how we do, let's see. In the network 1, save all the TI status into a data block in the first network, and in the last network all sep geo stored in a data block move into module geo, and this to be done in the last network.